Okay, so we have the limit of s squared over s plus 1 as x approaches negative infinity. So what I'm going to do is I'm going to do the same process that I did for the last one. We're going to start off with polynomial long division, and I'm going to sort of prove to you how it works. Same as last time. So we, again, same as last time. Fraction is just division. So what do we get? Leading term has to match up with this leading term. What do we have to multiply s by to get s? Another s squared. Multiply through, we get s squared plus s, right? Subtract that, we end up with a negative s. Sorry about that. Negative s. So now, what do we need to multiply this by to get negative s? Negative 1, right? So we get negative s minus 1, all of that minus, plus these cancel. We're left with a negative. Negative is a positive. We're left with just 1. So what we're going to get is plus 1 over s plus 1. All right? Makes sense. Okay. So now we can redefine the limit as x approaches negative infinity of s minus 1 plus 1 over s plus 1. And this is very similar to the one we did before. The only difference is now we have a variable alone by itself. So we can just evaluate. When you plug in negative infinity for s, you're going to get negative infinity. This is still minus 1. And this, since there's a variable in the denominator but not in the numerator, you plug in negative infinity, this is going to be 0. So what's this? Negative infinity minus 1 is negative infinity plus 0. It doesn't even matter what it is. So we're just going to get negative infinity. But again, doing all this division for something that should be an easy multiple choice or something that should take you a minute that you don't want to waste too much time on. This is a little much. So, like the other time, very easy trick. When you're taking it to either positive or negative infinity, all you have to look at is the power of the leading term of the numerator and the power of the leading term of the denominator. Here we have an s squared on top and an s on the bottom. Now, s is s squared. For s squared, as s approaches infinity or negative infinity, it's going to be either infinity or negative infinity. And as s approaches infinity or negative infinity, it's going to be the same thing. But since, if we look at the graph, since x squared increases more rapidly, it has a higher rate of change than x to the first. We basically, there's more rigorous definitions and reasons and proofs why this is, but we can say that as this goes to infinity, it's at any given value going towards it, it's going to be a larger value than s, than just s to the first, because this is going to increase infinitely faster than this is going to increase. So since it's going to negative infinity, this is going to decrease infinitely faster than this is going to decrease. That should make sense, but it's a little tricky to understand at first because they're both going to infinity, but it's that one is going to infinity faster than the other one is. So when you have the larger exponent, the higher exponent, or the leading term with the highest exponent in the numerator, and you're taking it to either infinity or negative infinity, it's going to be that, assuming there isn't a negative sign in front. And the same would go if we had something like s over s squared plus 1, the limit as x approaches infinity. Well, now this is just going to be 0. Because when you think about it, this, the bottom, what this is being divided by, is infinitely larger, is increasing infinitely faster than this is. It's infinity squared versus infinity. And it's a tough concept, but really when you think about it, if you were to do more long division like we did up here, you're going to end up with something similar to 1 over s, plus some constant, or some value here that's another fraction. But, and then when you plug in infinity into this for s, you're getting 1 over infinity. The bottom is increasing. It's infinitely large, which means we're getting infinitely close to 0, which means it's 0. And we can do that same proof for this. So, when your numerator is to a higher power than your denominator and you're going to infinity, the answer is going to be infinity. When the numerator is to a lesser power than the denominator and you're going to infinity, your answer is going to be 0. And then, if the powers are the same, you're just going to take the coefficients. All right.